Good morning. Today we're going to be talking about rational exponents. At the end, you should be able to simplify expressions that has rational exponents. And we're going to go from the basic knowledge that you already know, which is working with variables, to the more complex, which is radical expressions with exponents. It's going to be such an easy concept to grasp. Let's get started. Okay, so we are in chapter 6, lesson 4. We're going to be talking about rational exponents. Okay, and we are going to illustrate this using the concept that you already know. Okay, um, so the main concept that you gotta grasp from this is the following. If you have a radical like this, and it has a radicand with an index inside. Let's just go over this part real quick. This part is called the index. Okay, and of course this is a radical expression, radical symbol. Okay, and that's the exponent of the radicand. Okay, and of course whatever's inside of the house, we call that the radicand. Okay, so these are the basic parts of rational expression. Okay, so if you were to solve or simplify this radical expression, okay, you will have to think about these as a number with an exponent. Okay, so if you were to simplify this, you will take the radicand out of the box, and then you will take these two numbers and you combine them. You combine these two numbers, okay? Take that one and this one and you combine them. Into a fraction. Okay, so you're gonna build a fraction, okay, and the number that goes on the bottom, it's the index. Okay, this number becomes the denominator. Okay, so the 4, which is the index, becomes the denominator. Okay, and the number inside becomes the numerator. Okay, so you're gonna put the 3 on the top, and this is the exponent of the radicand. Okay, once you build this number, that number becomes the exponent that you are going to put in here. Okay, 3/4. And then that's actually the simplified form of this expression. Okay? So now we're gonna go over a couple of other different examples. Let's just go over a couple of examples. So if you have examples, okay? So if you have 36, and that's the square root of 36, okay? That is equal to 36, and then this one over here is 1, and this one over here is 2. Okay, so you are going to put the 1, this one on top, and then you're going to put that 2 on the bottom. And that will be the simplified form of that number. Okay, if you got 64 and then it's the cubic root of 64, the exponent of the radicand is 1. So you got to put the 64, which is the radicand, and elevate it to the exponent, which is going to be a fraction. You're going to put this one on the top as the numerator, and this one on the bottom as the denominator. And then this is the simple expression. Okay, and the same case goes with the 16. All right, that will be 16 to the power of 1 over 2. Okay, all right, so let's get into a couple of examples. So we're gonna do problem 1. Okay, and now this is simplification, so you're gonna simplify. Okay, so we're gonna go over a couple of examples. All right, example A, you got 216 over 1 to the power of 1 over 3. Okay, and you have to make that into a rational. Okay, so what you do is that you take the base, which is 216, and you are going to put that inside of the radical. Okay, now the bottom part of the exponent, it's the index that goes in here. Okay, and then inside the number has a 1. Okay, how do I know? I know it because the number that goes in there, it's the numerator. Okay, and there you have it. That's the simplified form for that number. How about case number letter B? Okay, where you have 7 over 1.5 times 7 to the power of 1.5. Okay, now if you take this number by itself, you are going to see that 7 to the power of 1/2, it's equal to the root of 7. Which root? Well, the 2, it's the denominator, goes outside, and the top number, it's the exponent. All right, so that will be the simplified form for that expression. therefore we can potentially say the square root of 7 times the square root of 7. And that is equal to the square root of 7 to the power of 2. This 2 cancels the radical expression, and therefore this becomes 7. And that is the answer to this whole equation. Okay? Let's do one more for safety measurements. Letter C, you got 5, and then you got 5 to the power of 1 over 4 times 125 over, or to the power of 1 over 4. Okay? So you are going to build your radical expression based on based on the exponents, right? Which happens to be the same, all right? So this is equal to 5, or the root to the 4th power of 5 times the root to the 4th power of 125. Okay? Don't miss this. Pay attention to this. If I were to do 5 plus instead of multiplication, I cannot do that. I cannot do that because I do have the same index, but I don't have the same radicand. In multiplication, you have to have only the same index, and then you can combine the two inside. So this is equal to 5 times 125, okay, which is equals to 625. All right, and you still gotta get that in a root format. Okay, all right, so now let's factor 625. Okay, pay attention. Watch. 625, okay? If we factor that by if we factor that 625 divided by 25, I'm gonna get 25 times 25. So 25 times 25, it's equal to 625. And when you factor these two, this is equal to 5 times 5, and then 5, it's prime, and then 5 times 5, okay? Remember, if we're dealing with the 4th root, let's group them in group of 4. So this is 5 to the power of 4, okay? So now when you simplify this, and you put 5 to the power of 4, you realize that they have the same key, so the 5 gets to go out of jail. So this is all equals to 5. Okay? Let me write it the right way so that you don't get confused. So this is equal to 5. Okay, and that's the answer. Okay. All right. So that is the actual concept of the whole problem. Okay. Okay. So let's do problem number 2. So we're gonna convert between exponential and radical form. Okay. All right, so here's the question. What are the radical forms of the following? Okay. X to the power of 3 over 7. Okay. Remember what I tell you before, that the top number, it's going to be the index, the exponent of the radicand. And the bottom number, it's going to be the index of the radical expression. Okay. And of course that the base, it's going to be the radicand. Okay. So you're gonna put the radicand inside of the radical expression, and then you are going to put the 3 on the radicand, and then you're gonna put the 7 as the index of your radical expression. Okay. Now let's deal with y to the power of minus 3.5. Okay. So 3.5. Okay. Now 3.5, when you negative 3.5, let me put it over here in a corner. Negative 3.5. Okay. You got to be able to turn that into a fraction. Okay. So when you put that on to the power of 1 and you move this sign over here, okay, and you got to move one position here, now you got 35 divided by 10. Okay. And when you simplify this thing, 5 divided by 35 is 7, and 10 divided by 5 is 2. Okay. So this expression, it's equals to minus 7 over 2. Okay. And the same rules apply. Okay. The same rules apply. That's the radicand. Okay? And then this is the index, okay? And the exponent of the radicand, all right? Goes there. It's the same story. So you are going to put the radicand inside of the radical expression. You're going to take these two over here and you're going to put it outside, and then you're going to take that 7 and you're going to put it inside. Do you see the difference? On this case, the 7 was on the bottom, therefore the 7 goes outside. On this one, the 7 was on the top, so the 7 goes inside. Okay? Alright, so now I'm gonna give you a couple of properties, okay? For these rational exponents. Okay, so these are just properties. Okay? For instance, a to the power of m times a to the power of n, it's equals to a m plus n. Okay? Example, 8 to the power of 1 over 3 times 8 to the power of 2 over 3. Okay? Listen, this is the most important part. They gotta have the same base. So they gotta have the same base, alright? So this is equal to 8, alright? And then you add 1 over 3 plus 2 over 3. Okay? So this becomes 8. 1 plus 2, it's 3. And then it's the same denominator. So 3 over 3, it's 8 over 1. Okay? All right. The other property, it's what we call nested exponent. All right? When you have a situation like that, this is equal to a m times n. I want you to notice the difference. Okay? In this case, it's being multiplied by different exponents. In this case, it's a nested exponent. Alright? So these are two different situations. Alright, here's the example. 5 to the power of 1 over 2, and all of that elevated to the power of 4. Okay? So now you gotta take the same base and you gotta take 1 over 2 and multiply it by 4 over 1. Okay? And this is equals to 5, and then 1 times 4, it's 4, and then 2 times 1, it's 2, and 4 divided by 2, it's 2. Okay? Again, I want you to notice that we are talking about the same base all the time. Okay? Next, it's when we have two numbers elevated to a power. Okay? You will have to apply that power to each one of the numbers. Therefore, this is a to the power of m times, right? Because when you have two letters or two numbers together, this is a multiplication. Okay? So this is A times B to the power of M. Here's the example. 4 times 5 divided or multiplied by 1/2. Okay? So this becomes 4 to the power of 1/2 times 5 to the power of 1/2. Okay? All right? Um, okay, so now a couple of minor properties that you should know. A, okay, hang on, let me fix this part. Okay. And then you have A to the power of minus something, okay? Every time you see a minus on the exponent, like here, okay? What you do is that you are going to take the original number and you're gonna put it positive now, and then you're gonna put a 1 on top. Okay? Here's the example. 9 to the power of -1/2. Okay? So this is equals to negative to the power of 1/2 over 1. Okay? And then you solve that thing. Look. 9 to the power of 1 divided by 2. It's equal to 3. So this is equal to 1 over 3. Okay? Alright. Here's the next property. AM divided by AN. Okay? When you have a division, what you do is that you take the top one and then you minus bottom. Okay? So what you do is that you take the number that, remember, they gotta be the same number. Okay? Okay. So you take the top one and you subtract that to the bottom one. Okay? Here's the example. 7 to the power of 3 over 2 divided by 7 to the power of 1/2. Okay? So this is equal to 7 top 1 3 over 2 minus bottom 1 1 over 2. Okay? and that is equal to 3 minus 1, it's 2 over 2, so 7 to the power of 1. Okay? And last but not least, A over B, all of it to the power of something. Okay? So you gotta take this exponent and apply it to the top one and apply it to the bottom one. Okay? So this is equals to A M over B M. Okay? And here's the example. 5 over 27, right? To the power of 1 over 3. So I will have to take this number and apply it to that one and apply it to that one. Okay? So this will be 5 to the power of 1/3, 27 to the power of 1/3. Okay? And look, when you do 27 to the power of 1 over 3, that's equal to 3. Okay? Now 5 to the power of 1/3, it's gonna be a decimal number, so we're just gonna leave it to the simple expression. Let's see if that's the case, which I believe it is. Yes, you see, so because this is a decimal number, the simple form of the expression is the way it is right now. So we're just gonna put it over here. Okay? Alright, so those are the properties that you are going to be using to solve your problems in this section. Okay? So let's do an example on how is it that you can be using these properties. Okay? For example, okay, let's say you have okay, so here's the example. Okay, so this is the example. Okay, the fourth root of x to the power of 3, and then the eighth root of x to the power of 2. Okay, so you need to convert this into exponential fraction. All right, so this is equals to x, and then you're gonna put a fraction in here, so you're gonna put 4 over 3. Okay, in this case you put x 2 over 8. Okay, so now that you have a division of exponents, you're gonna find what is the property that you are going to be using, which seems to be this one. Okay, so I'm going to take the same base and I'm gonna take the top exponent and I'm going to subtract it to the bottom exponent, okay, like so. All right, from your earlier math, you know that when you have different exponents like this, you've got to use the butterfly method, right? Okay, the butterfly method. In this method, you take these, you cross them by multiplying them. So 3 times 8, it's equal to 24. And then 4 times 2, it's equal to 8. And then you take this symbol and then 24 minus 8 and you combine the two. All right, so 24 minus 8, it's 16. Okay, so the solution to this, you take these two and you multiply them together. 4 times 8, right, equals 32. And that's gonna be your new denominator. Okay, and then you put 24 minus 8, 16. Okay, now you can reduce this to 1 over 2, okay, because 2 times 16, it's 32. All right, so this is equals to x 1 over 2. Okay, so that's the example. So I'm gonna ask you to do from the classwork that you should have gotten already. All right, so you should have gotten this one, this page over here. So I'm gonna ask you to do from 10 to 34. From 10 to 34. Okay, so all of it you need to do. If you got any questions, you can ask the proctor to explain to you how to simplify it. As soon as you get it all done, make sure you upload it to your Teams assignment. You're gonna see the radical exponent assignment in here. Make sure that's the one you use to upload your work. So that'll be it for today, folks. If you have any questions, I'm going to attach the whiteboard to the assignment. I'm also, of course, I'm gonna attach this video. You're gonna have the classwork in there. You're gonna have the curriculum. If you got any questions, just ask your proctor, and I'm sure you're gonna be enlightened by him. Just ask the questions, and he'll take the time and explain it to you. All right. So I hope you have a wonderful day.